Cinematic science storytelling, scattered element style. The universe began not with a whisper, but with a silent unfolding. A moment so small, so impossibly brief, that even the sharpest human mind struggles to imagine it. And yet, from that flicker, every planet, every atom, every heartbeat we know today was born. But this chapter is not only about where the universe came from. It's about how humans learned to see it. Because the universe doesn't speak, it glows, it moves, it pulls, it sculpts, and slowly, across thousands of years, humanity learned the language of the cosmos. Long before telescopes, long before formulas or equations, ancient humans stared up at the sky and felt the same thing you and I feel today. A mix of wonder and confusion. Why do stars shine? What are the lights drifting across the sky? Why does the sun disappear, then return? Every discovery we celebrate today, from gravity to atoms to galaxies, began with someone who simply looked up and asked, "What is that?" In those early nights, the sky wasn't science. It was myth, story, fear, and hope. The universe was a puzzle so enormous that humans could only scratch its surface. But even then, curiosity had already awakened. Picture a young human, thousands of years ago, sitting near a fire, holding a small stone in their hand. They drop it. It falls. No formula, no physics, no Newton, but a pattern is noticed. Stone always falls. Smoke always rises. Fire always warms. Water always flows downward. The first experiments weren't in laboratories. They happened beside rivers, under trees, near fire pits, in caves. Every simple observation became a stepping stone toward understanding the cosmos. Humanity didn't know it yet, but science had begun. Over centuries, humans learned to track the sky. The stars became maps for travelers, calendars for farmers, and secrets for early thinkers. Constellations weren't just shapes. They were clues. Why do stars stay in patterns? Why does the moon change shape? Why do some stars move differently from others? Those wandering lights were planets. No one knew it yet, but the sky was already revealing the structure of our solar system. Humanity was learning to read the universe, symbol by symbol. As societies grew, so did ideas. In ancient Egypt, Babylon, India, China, Greece, thinkers began to challenge the old stories. They asked, what if the universe follows rules? What if nature is consistent? What if everything, stars, stones, storms, humans, is part of one connected system? This thought changed everything. Because once humans began imagining that the universe has laws, we started searching for them. Curiosity transformed from a feeling into a tool. The biggest shift came with the realization that not everything true is visible. Wind can't be seen, but it moves the world. Gravity can't be touched, but it holds galaxies together. Atoms can't be viewed with eyes, but they build every grain of matter. Humanity began understanding that the universe is not just what we see, but what we infer. This new way of thinking was like a flame catching dry grass, an explosion of ideas. By the time early scientists, Aristotle, Al-Biruni, Newton, entered the stage, curiosity had evolved into a discipline. Mathematics became the language. Observation became the method. Reason became the torchlight shining into the dark. The universe, once unknowable, now began to reveal itself. Planets weren't gods. Stars weren't holes in a blanket. Earth wasn't the center of everything. For the first time, humans realized, we are part of a vast, expanding, ancient creation, and we have the tools to understand it. And so, from those early firelit experiments and sky maps, from myths and questions and quiet observations, a path was built, a path that leads directly to you. Every video you watch today, every documentary, every equation in textbooks, every image from telescopes, they all descend from the first moment an early human dared to wonder. Cinematic science storytelling, scattered element style. The universe had offered humanity its first whispers through falling stones, shifting stars, and the rhythm of nature. But now the story deepens. If Chapter 1 was about learning to notice the universe, then Chapter 2 is about learning to enter its smallest secrets. Because everything you touch, every breath, every drop of water, every star in the sky, is built from tiny, invisible bricks. This chapter is the tale of how humans discovered them. For thousands of years, people believed matter was continuous, that you could break anything into smaller and smaller pieces forever. But then came a revolutionary idea. A thought so strange, so ahead of its time, that the world wasn't ready to understand it. What if matter is made of indivisible pieces? The Greeks called these pieces atomos, the uncuttable. It wasn't science yet, it was a guess. But it planted a seed that would grow for centuries. Even without microscopes, the universe left hints. Why does scent travel across a room? Why does heat spread? Why do liquids mix? Why does metal expand when heated? These were clues, tiny signatures of particles too small to see, constantly moving, colliding, dancing. Nature was whispering. Look closer, even closer. But humans had no tools yet to see the hidden architecture. So the mystery slept, waiting for the right minds to awaken it. Centuries passed. Then, during the scientific revolution, curiosity sharpened. Tools improved. Glassblowers created precise tubes. Inventors made vacuum pumps. Scientists experimented with gases. And suddenly, matter behaved strangely. A gas expands to fill its container. Pressure changes with temperature. Some substances combine in perfect, predictable ratios. These patterns screamed. Matter isn't continuous. It's granular, structured, mathematically organized. John Dalton stepped forward. He didn't see atoms, but he proved their existence through logic. Every element, he declared, is made of a unique type of atom. The world beneath the world was becoming clearer. The next breakthrough came from something no one expected. Electricity. Scientists noticed that invisible rays inside glass tubes bent in magnetic fields, as if tiny charged particles were racing through the tube. J.J. Thomson named them electrons. This was the first time humanity had discovered a piece smaller than an atom. The ancient idea of indivisible matter shattered. Atoms weren't the smallest building blocks. They had internal structure, a universe within a universe. The door to modern physics creaked open. Next came Rutherford. He fired particles at gold foil, expecting them to pass straight through. Most did, but a few bounced back as if they hit something incredibly dense. Something tiny, something powerful, a nucleus. Humanity had discovered that atoms had hearts, small, charged centers containing almost all their mass. And orbiting around them, electrons. The atom was no longer a simple idea. It was a system, organized, elegant, dynamic. But when scientists looked even closer, reality became strange. Electrons didn't orbit like planets. They behaved like both particles and waves. They existed in clouds, in probabilities, in states of possibility. The deeper humanity looked, the more the universe whispered, "I am not what you expect." Quantum mechanics was born, a new language for the hidden world. A language in which particles can be waves. Nothing is ever fully still, and emptiness is never truly empty. The architecture of matter was deeper, richer, more poetic than anyone had dreamed. By the end of the 20th century, scientists had mapped an entire zoo of subatomic particles. Protons, neutrons, quarks, gluons, neutrinos. Everything you see, the oceans, forests, clouds, buildings, planets, stars, is made from just a handful of fundamental ingredients. The universe, it turned out, is built like music. A small set of notes, endless combinations, infinite beauty. Today, when we speak of matter, we're not talking about solid chunks. We're talking about energy fields, quantum states, invisible forces, and vibrations woven through space-time. It took humanity thousands of years to understand this, to look beyond the surface and glimpse the breathtaking machinery underneath reality itself. Every grain of sand is a galaxy of motion. Every atom is a story. Every particle is a verse in the cosmic poem. And this chapter ends with one revelation. To understand matter is to understand the universe. Because everything, from you to the stars, is made of the same ancient dust. If the universe is built from tiny particles, then there must also be something that tells those particles how to move, how to interact, how to shape reality. This chapter is about the invisible rules of existence. The forces that sculpt everything from dust clouds to galaxies, from the spark in a wire to the warmth of sunlight on your hand. These forces are ancient, powerful, and woven into everything. Imagine the universe as a stage. Particles are actors, but without direction, they would wander randomly. So nature created four fundamental forces: silent directors guiding every motion. Gravity, electromagnetism, the strong nuclear force, the weak nuclear force. Each one is unique. Each one plays a role in the cosmic story. And together, they make reality possible. Gravity is the oldest, slowest, gentlest force, yet it sculpts the grandest structures in the universe. A force that pulls everything with mass toward everything else. A star forms because gravity squeezes gas into fire. A planet orbits because gravity bends space into curves. Your feet stay on the ground because Earth is holding you close. Einstein showed us something deeper. Gravity isn't really a pull. It's the bending of space-time itself. Matter tells space how to curve. Space tells matter how to move. From falling apples to spiraling galaxies, gravity is the quiet architect of the cosmos. If gravity builds the universe, electromagnetism gives it color, shape, structure, and energy. It binds atoms together. It powers electricity. It carries radio waves. It makes magnets pull and push. It gives us light. Every spark, every signal, every heartbeat is driven by electromagnetic interactions. Electrons dance because of it. Atoms bond because of it. Your eyes see because photons, tiny packets of electromagnetic energy, touch the cells in your retina. Without this force, matter would fall apart. Stars wouldn't shine. Life couldn't exist. It is the universe's most expressive painter. 4. The strong force, the cosmic glue. Now zoom deeper. Inside every atom's nucleus, protons and neutrons sit packed together. But protons should repel each other. They're all positively charged. So why doesn't the nucleus explode? Because of the strong nuclear force, the most powerful force in the universe. It binds quarks into protons, protons into nuclei, and nuclei into the atoms that build everything. If gravity shapes galaxies, the strong force shapes the very cores of matter. Without it, elements wouldn't exist. Stars couldn't forge heavier atoms. You, and every object, would dissolve into a dust of loose particles. The strong force is the cosmic glue that holds existence together. The weak nuclear force lives up to its name. It's gentle and subtle. But don't be fooled. It is the reason the universe changes, evolves, and ages. The weak force enables radioactive decay, fusion in stars, creation of new elements, the balance of matter in the cosmos. Every time a star turns hydrogen into helium, the weak force is whispering in the background, transforming particles and giving birth to energy. It is the silent alchemist of nature. Alone, each force is powerful. Together, they form a cosmic symphony. Gravity gathers clouds of dust. Electromagnetism ignites them into stars. The strong force shapes elements inside those stars. The weak force transforms those elements into heavier ones. And eventually, those atoms become planets, oceans, life, you. This cooperation is not accidental. It is the universe's way of weaving complexity from simple ingredients. The forces are not separate. They are a single story, told in 4 voices. Scientists dream of something more, a grand theory that unifies all forces into one elegant equation. We've unified electricity and magnetism. We've unified electromagnetism and the weak force. Someday, perhaps, gravity will join too. Until then, the forces remain mysteries, beautiful, powerful, and endlessly intriguing. Every thought you have is an electrical signal guided by electromagnetism. Every breath you take comes from atoms held by the strong force. Your body exists because gravity keeps you anchored to a planet that formed through these forces. You are the sum of cosmic interactions, a harmony of physics written across billions of years. This is the story of forces, the unseen powers that sculpt the universe. How the universe forged the ingredients of life. Everything you touch, everything you see, everything you breathe, is made from elements. But these elements were not always here. Once, the universe had no atoms, no carbon, no oxygen, no gold, no iron, not even the dust beneath your feet. There was only energy. Pure, blazing, expanding energy. This is the story of how that energy became the ingredients of stars, planets, and life itself. For the first few moments after the Big Bang, the universe was a storm of unimaginable heat. Temperatures so extreme that atoms couldn't exist, they would be ripped apart instantly. In that early chaos, Light flashed everywhere, particles popped in and out of existence, space stretched faster than the speed of light. The universe was a glowing ocean of pure energy. Matter was possible, but not stable. The universe had to cool. It had to calm down. Only then could creation begin. As the universe expanded, its temperature dropped. Within the first second, energy slowed enough for tiny particles to settle. Quarks, electrons, neutrinos. Quarks, pulled together by the strong nuclear force, combined to form protons, neutrons. These were the seeds of atoms, the bricks from which all elements would be built. But the universe was still too hot for full atoms to form. The universe had the ingredients, but not yet the recipe. About 3 minutes after the Big Bang, something miraculous happened. The universe cooled just enough for protons and neutrons to fuse into the first atomic nuclei. This event is known as Big Bang nucleosynthesis. It produced the earliest, simplest elements. Hydrogen, the first and most abundant. Helium, the second, tiny traces of lithium. These elements were the universe's first meaningful creation, the opening chapter in the story of matter. But heavier elements? Carbon, oxygen, iron, gold. They were still impossible. The universe needed stars before it could write the rest of the periodic table. Hundreds of millions of years later, gravity worked its slow magic. Clouds of hydrogen and helium collapsed, squeezing tighter and tighter until the pressure lit a fire. The first stars were born, and with them, the universe gained its first great forges. Inside their blazing cores, temperatures soared to millions of degrees. Here, protons fused together, creating new elements step by step. This is where nature unlocked its greatest power. Stellar nucleosynthesis, the creation of elements inside stars. Inside stars, the journey of creation unfolded like a ladder. Hydrogen, helium, the simplest fusion. Helium, carbon. Carbon, oxygen. Oxygen, neon. Neon, magnesium. Magnesium, silicon. Silicon, iron. Every step required more heat, more pressure, and more time. When a star forged carbon, it forged the backbone of all life. When it forged oxygen, it set the stage for water, oceans, breath. When it forged iron, it reached the limit, because fusing iron absorbs energy instead of releasing it. And when a star reached this point, its life was almost over. The most dramatic chapter was about to begin. When a massive star builds up an iron core, it becomes unstable, like a tower built too tall. Gravity crushes it inward. The core collapses in a fraction of a second. And then, a supernova explodes. This explosion is one of the most powerful events in the universe. In those brief moments, temperatures soar higher than the center of stars, and heavier elements are created. Gold, silver, uranium, lead, platinum, copper, iodine, and dozens more. The universe's most valuable materials are born from destruction. The death of a star creates the life of new elements. Some of the rarest elements come from something even more extreme. Neutron-star mergers. When two ultra-dense dead stars collide, a shower of neutrons bursts outward. In these conditions, atoms rapidly capture neutrons, a process called the R process. This creates gold, silver, platinum, rare earth metals. Every ring of gold on Earth, every piece of jewelry, every electronic component comes from violent cosmic collisions that happened billions of years ago. Your favorite metal is older than the Earth itself. The elements created in stars and supernovas drifted across space for billions of years. Clouds of debris mixed with gas and energy. Gravity gathered them again, forming new stars, new planets, new possibilities. On one small world, orbiting an ordinary star, those elements combined into oceans, rocks, soil, plants, animals, and eventually you. Everything in your body was forged in ancient cosmic fire. You are literally made of stardust. This is not a metaphor. It is science. Carbon in your DNA, iron in your blood, calcium in your bones, oxygen in your breath. All of it was born in the hearts of stars. The universe didn't begin with complexity. It began with simplicity. Hydrogen, helium, light, energy. But through time, gravity, heat, fusion, and cosmic violence, it sculpted the elements needed for galaxies, for solar systems, for planets, for chemistry, for biology, for thought, for love, for you. The birth of elements is the birth of everything. It is the universe's greatest transformation, from emptiness to existence. The universe built the ingredients. But how did they shape everything that came after? Elements are not just materials. They are the script of the universe, the silent actors shaping worlds, sculpting landscapes, building life, and guiding the destiny of planets. Every place you've ever seen, every mountain, every ocean, every desert, is a reflection of the elements that formed it. And every living creature, from single-celled microbes to trees to humans, is a story written in the alphabet of atoms. This chapter reveals how elements created the diversity of the cosmos, and why understanding them is the key to understanding ourselves. If you look at the periodic table, you're not just seeing symbols, you're seeing characters. Every element behaves differently. Some attract electrons, some repel fiercely, some bond with anything, some stay alone, some burn instantly, some glow beautifully, some are heavy like anchors, some are so light they float away. These differences decide why planets have different atmospheres, why oceans exist, why mountains rise, why life is possible, why you can breathe, move, and think. In the chemistry of the universe, personality is destiny. The composition of a planet decides what kind of world it becomes. A planet rich in iron forms a solid core and a magnetic shield. A planet with abundant carbon can produce organic molecules. A planet with sulfur becomes volcanic and unstable. A planet with lots of water molecules forms oceans and storms. Earth is only Earth because of the elements it inherited. Change the ingredients, and you change the world. On Venus, carbon dioxide traps heat, turning the planet into a furnace. On Mars, a lack of atmospheric oxygen leaves the surface red and barren. On Jupiter, hydrogen and helium create storm belts larger than continents. Every world is a chemical poem. Out of all the molecular combinations the universe could have chosen, one stands above all. H2O. A simple connection between hydrogen and oxygen became the foundation of life. Water carries nutrients, shapes landscapes, moderates temperature, dissolves essential minerals, supports chemical reactions, allows cells to function. Without hydrogen and oxygen joining forces in perfect harmony, Earth would be a silent rock floating in darkness. Life's greatest medium is a gift of elemental chemistry. Life needs flexibility. Life needs complexity. Life needs structure. And carbon is the only element that can provide all three. Carbon chains bend, twist, branch, and form rings. Carbon bonds are stable yet versatile. Proteins, DNA, lipids, sugars, all exist because carbon allows them to. Carbon is the universe's most creative artist. Without carbon, life as we know it would be impossible. It forms the core of Earth, it generates our magnetic field, it protects us from solar radiation. And inside the human body, iron binds oxygen, allowing you to breathe, to walk, to think. Every heartbeat is powered by iron atoms forged in ancient stars. Inside you is stardust still doing the job it was created for. Life is chemistry at the most delicate scale. Inside every cell, sodium creates electrical signals, potassium balances fluids, calcium triggers muscle movement, phosphorus stores energy in ADP, nitrogen builds proteins and DNA. Carbon forms the backbone of molecules, hydrogen bonds hold everything together. Your body is a universe of billions of reactions happening every second. Life is not a miracle. Life is chemistry arranged with purpose. The story doesn't end with biology. Human civilization advanced because we learned to harness elements. Copper and tin gave birth to the Bronze Age, iron forged tools and armor, silicon built the computer age, lithium powers modern batteries, gold conducts signals inside your devices, rare earth metals allow satellites and smartphones. Every invention, every machine, every discovery originates from the periodic table. The elements that once formed stars now form the technology that lets humans explore them. Pause and think. You are not separate from the universe. You are a continuation of it. Carbon atoms in your cells once lived inside a star. Calcium in your bones came from ancient supernovas. Iron in your blood was forged in cosmic fire. Oxygen in your lungs was created billions of years ago. Hydrogen in your body is as old as the Big Bang itself. You are the universe made conscious, made curious. You are the elements looking back at the stars that created them. The elements that built you will one day return to the universe. Billions of years from now, stars will die, new planets will form, and the atoms that once lived inside humans will shape new worlds. This is the legacy of elements. Nothing is ever lost. Everything transforms. Everything returns. Everything begins again. Elements are the universe's longest story, and we are living inside its newest chapter.